Hi guys, I have got some of the doubts from your side. So let us start the webinar. I'll be taking doubts one by one. In the meantime, if you would like, you can post other doubts on the QA section. I shall deal with those doubts also. Let me take the first doubt. Is discrete time Fourier transform same as the Z transform? So the answer to this question is no. Basically, what is discrete time Fourier transform? It is represented as x e raised power j omega. It is summation n equal to minus infinity to plus infinity xn e raised power minus j omega n. Whereas z transform is x of z, that is summation n equal to minus infinity to plus infinity x of n z raised power minus n. As we already know that the continuous time Fourier transform is nothing but special case of Laplace transform. Laplace transform converges to when s is equal to j omega, or we can say on the imaginary axis. Similarly, what happens? This z transform converges to discrete time Fourier transform when mod z equal to 1, that is unit circle. And when unit circle lies in ROC, we can say that the system is stable. So what I can say is, for stable system, we can say that the discrete time Fourier transform exists, and for unit circle, Z transform converges to Fourier transform. Okay. Guys, this time around, are you able to hear me? Or this time also you are having a problem of noise or voice, anything, if you are not able to get me? Please let me know in this question section only. Anyone, if I am audible? Guys, please let me know if you are able to hear me. Okay, thank you. One person has commented that I am audible. So let us skip to next question then. Guys, please let me know if you are able to hear me. The next question is, use of Tacho generator as a minor loop feedback in closed loop control system to limit the speed of motor, to limit the acceleration, to reduce damping, to improve stability of the system. Okay. So let us take an example. Suppose this is my forward path transfer function. Let us say 1 upon s into s plus 2 or s plus 1, let us say. Okay. Here let me take a Tacho generator feedback. Let me consider it as unity feedback system. Now without the Tacho generator, what would have happened? The forward path transfer function would have been 1 upon s into s plus 1, and the feedback would have been unity. Now what would have been the closed loop transfer function? 1 upon s square plus s plus 1, for which natural frequency is 1 and damping ratio is how much? It is half. Now when we have this Tacho generator feedback, then first I will calculate the transfer function of the inner loop. So what happens for the transfer function of inner loop? GS is actually 1 upon S into S plus 1 and HS is equal to S. So what is transfer function? It is 1 upon S into S plus 1, 1 plus 1 upon S plus 1. So how much will it come out to be? 1 upon S into S plus 2, 1 upon S into S plus, or let us leave it as it is. Okay, this is the inner loop. Then what will be the overall transfer function? 1 upon S square plus 2S plus 1. For this case, zeta comes out to be 1. That means damping ratio increases. If damping ratio increases, then what happens? If damping ratio increases, that means what happens? Acceleration of the motor is limited. Okay, or we have reduced the acceleration by increasing the. Is it fine? So that is the effect of tacho generator in the inner loop of the speed control of DC motor. Is it fine? But since the system remains second order, so the stability is judged by positiveness of the coefficient. So the system was initially stable and right now also it is stable. But what happens to its relative stability? If you see the poles location, now there are two poles at -1. Earlier there was complex conjugate poles. Earlier poles were closer to the origin, so it was less stable. Now it has become more stable as the poles have moved away from the origin. That means by the use of tacho generator in the feedback loop, stability also improves. But basically tacho generator is used to limit the acceleration of the motor. Also guys, you have buttons of like and dislike below the video that you might be watching. So by clicking on the like, do let me know if your doubt is cleared. Otherwise, I will try to find another suitable way to explain the same problem so that you gain something from this webinar. Till then, let us move on to the next problem. The next question is basically root locus of 5 upon s plus 5. Since in any root locus k variable is given, so we vary k from 0 to infinity. But here k is constant 5. How to draw it then? If k is constant 5 and we have open loop transfer function as 5 upon s plus 5, then the closed loop transfer function will become 5 upon s plus 10, which has a pole at s equal to -10. Here I am assuming that the system is unity feedback, and this thing you should also do whenever feedback is not given to you. You can assume unity feedback without losing any property. Now basically the root locus entirely is reduced to a point which is the pole at s equal to -10. There will be no locus or no shape because there is no variable in the root locus plot. You are not varying any parameter, hence there will be only a single pole. Let us move on to the next problem. The loop transfer function of a feedback system GS into HS is given to me as s plus 3 upon s square s minus 3. So guys, pay attention to this question. This question was asked in GATE 2016. It is kind of important question as many students had misconception about it. For when we are dealing with Nyquist plot, let me explain one concept that we have two types of things, or we have two things defined. First one is known as Nyquist contour. Nyquist contour is basically a set of values in the S plane for which we will be plotting the Nyquist plot. So it is nothing but the entire right half plane which is covered by means of an infinite semicircle and the j omega axis, excluding the poles, that is no poles must lie on the Nyquist contour. Suppose these are the poles on the j omega axis. Then how do I draw a contour? I draw like this. This is infinite semicircle. Then I go bypass the poles. Okay. So basically, Nyquist contour has mainly four parts. One is the infinite semicircle. One is j omega axis minus j omega axis, and one small semicircle which is to go around any pole. So these are the four parts in any Nyquist contour. And as you can see from the figure, Nyquist contour is always clockwise. So there is no catch in this problem when it is said that Nyquist contour is oriented clockwise. The concept still remains the same. Now it is asking how many times does the Nyquist plot encircles minus 1 plus j0 point. By Nyquist stability criteria, we know n equal to p minus z, number of encirclement equal to number of open loop poles in the right half plane minus number of closed loop poles in the right half plane. From the transfer function, there are two poles at origin and one in the right half plane. So p is 1. Now what we need to find is, we need to find the number of closed loop poles in the right half plane. For that, let me construct the characteristic equation. It will be 1 plus GSHS equal to 0, which means S square S minus 3 plus S plus 3 equal to 0. Or we can say S cube minus 3S square plus S plus 3 equal to 0. Then if we plot the Routh array, 1, 1, minus 3, 3. The next will be minus 3 into 1, minus 1 into 3, minus 3, 2, and then it will be 3. As you can see, there are two sign changes. So there are two closed loop poles in the right half plane, z equal to 2, which means n equal to 1 minus 2, that is minus 1. So minus sign indicates clockwise encirclement. Hence the Nyquist plot encircles minus 1 plus j0 point once in the clockwise direction. Okay, so that will be the answer. Otherwise, what you can do is, you can also plot the Nyquist plot in order to know how many times does it encircle. So let us try and draw the Nyquist plot. S plus 3 upon S square S minus 3. So first of all, let us convert this into j omega. J omega plus 3 by minus omega square j omega minus 3. Now if we take the magnitude, it will be 1 by omega square, because magnitude of this and this term will get cancelled out. What about phase? Phase will be tan inverse omega by 3 minus 180, because 90 and 90 will be 180. Then j omega minus 3 second quadrant, so it will be 180 minus tan inverse omega by 3. So it becomes 2 tan inverse omega by 3 minus 360. Now omega equal to 0, magnitude and phase. So at omega equal to 0, magnitude is infinite and phase is how much? Minus 360. And omega equal to infinity, magnitude is 0 and phase is how much? Minus 180. So since the phase is varying between minus 180 and minus 360, it is lying in the first and second quadrant. And how does the Nyquist plot look like? It starts from minus 360 and ends at minus 180. Then we will plot a mirror image. And now since the type of the system is 2, we have to draw two infinite semicircles, which will be drawn like this. And remember, infinite semicircle is always clockwise. Since minus 1 will lie inside the infinite semicircle, so it is encircled once in clockwise direction. That could be other method of finding the number of encirclement of the critical point. Is it fine? So these two methods can be generally used. Next doubt. This I think I saw on the group also. How to find the resistance when RL and RC elements are connected in parallel with a AC source. So remember, if any such question you face where it is asking the value of resistance so that the circuit becomes independent of frequency, then what you have to do is there are two concepts. One is independent of frequency, other is known as distortionless transmission, that is input and output is not distorted. In both the cases, what you have to do is equate the two time constants in the circuit. So here the two time constants are, one is the RL time constant which is L by R, other is the RC time constant which is RC. So R square is equal to L by C, which means R is equal to under root L by C. So in that case, the circuit will be independent of frequency at all frequencies. Is it fine? So that is how we can find the value. Now let me check if there are any other questions. Next one is, in polar weather we use RMS value or the maximum value. Basically, in many books of network analysis, you will find that the phasors are drawn with respect to the maximum value or the peak value. But whenever you are drawing a phasor, the length of the phasor is the RMS value of the quantity. Okay. So that is what we generally prefer in electrical engineering, that it is the RMS value. Next is, please explain all the parameters on which beta of a transistor depends and varied. Beta basically is the gain of the transistor, which is IC upon IB. It depends on the area or the cross-sectional area of the transistor, because if we assume current density is as constant, then current depends on the area. So that is the biggest parameter. Then the other parameters could be lifetime of the carrier, diffusion length, and many other parameters, but the most dominating one is the area of the junction. Okay. So are there any other doubts, any other questions that you would like me to solve directly here? If there are any, please post them right now. And guys, since it has been almost 3 to 4 months since we have been running this course, it would be very good if you could also pick up the pace. Otherwise, a very less time will be left at the back end of the course. Read the question banks that we have sent you guys. Also try to solve as many problems as possible from different sources. You can follow standard books, our study material, and try to post your doubts. Try to get it clarified so that in the long run you will be benefited. Because at present what I am feeling is that you guys are not putting in that much effort as you should be putting. As you can also see that Gate Electrical is one of the toughest paper out of all the branches. So you have to put in extra effort. This kind of effort that you are putting right now will not benefit you in the long run. So kindly start working harder, because right now I don't think that you are going on the right path. Other than that, if you have any doubts, please post it on the group and try to attend the webinars that we are conducting, and try to have your doubts prepared before that, so that those can be solved people and everyone can benefit from that. The next webinar we will be conducting in the month of June, in the first or the second week. So try to cover some subjects or some topics by then and have your questions ready. So now I will be concluding this webinar. I will be ending this broadcast. If you have any other doubts, then please post them on the group. Okay, thank you.